Dear students, welcome to my YouTube channel PCM Academy. We are in a lecture series of quantum mechanics for IT JAM, JEST, NET, GATE, this kinds of exam. So basically I will cover the syllabus of IT JAM first, then I will move to the advanced section also. So today we will discuss the more about the commutation relation. We have start commutation relation in the last class. Some commutation relation between position and momentum I have discussed. But today we will discuss something more about commutation relation. And before going to that part, let me tell you about some important property of commutation relation also. Okay, so let us first tell you about some important property. So properties of commutation relation. Properties of commutation relation. Okay, so very first property is that if you have a cap b cap is equal to b cap a cap, that if a cap and b cap commute each other, then you can tell it that this is the anti-symmetric relation. This is nothing but anti-symmetric relation. Okay, now one more important property is the linearity property. So you can say linearity property. So what this linearity property is, if you have three operators a cap, b cap and c cap, something like a cap comma b cap plus c cap, then you can write it in this way, that is a cap b cap first plus a cap c cap. So you can write this way. Now the most important thing about commutation relation, that is the associative property that I will use here. Okay, so that is associative property. Associative property. Associative property. Suppose you have three operators again a, b, c, and we have in this from a cap comma b cap c cap. So this can be written as a cap c cap first, okay, then b cap plus b cap c cap, and then a cap b cap, in this way. But something, if this associative property can be written in this way also. Suppose a cap b cap first and then c cap. Now how can you write this? So this will be first a cap with c cap, then b plus first a cap with c cap, then with b cap with c cap, then a here. So just you can write in this way. So this is also the associative property. Okay, so you have to keep in mind, just if multiplication is after comma or before comma. So first, if in this way there is after comma there is multiplication, so first a with c, then a with b, and here also a with c, then b with c. So in this order you have to write. Okay, and if any operator, the commutation relation of any operator with just a scalar number a, so that will always be 0. So you should keep in mind this also. This will always be 0. Okay. Now let us use these properties. This is basically this associated properties. Okay. So we have already proved in the last class that if we have position and momentum operator, something like x cap with px cap, no. So this is just I h cross. And please keep in mind, if you need px cap with x cap, then it will be just minus I h cross. Now what we want to do is actually, if x square with px, suppose we have x square with px, then what you should do, or how you should do it. So this can be written as, this x square can be written as x cap into x cap and px cap. Now you can open this something like a cap b cap comma c cap. So how? First you have to write this with this, and then you have to write this with this. So this will be just x cap p x cap, and one x cap is outside, plus again x cap is outside, and this is x cap comma p x cap. So as this is IH cross, so this that will be IH cross x plus IH cross x, so that will be simply 2IH cross x. So your x square with px will be simply as 2IH cross x. Okay, now if you have x cube and px, so if you have x cube with px, then what will happen? Suppose you have x cube with px. Now x cube can be written as x into x square. It can be written as something like x cap into x square cap comma px. You can open in this way. Now how you can write it? Okay, so again you have to open in this way, that first x with px, then x square with px. So when x with px, then x square will be outside, plus when x square will be outside, then you will have x with px. Now this is what actually is the x with px, means this is IH cross x square, something like x cap, sorry, when x square with px, then x will be outside, so it will be x square with px. Okay, so plus, and this is IH cross x square plus x cap into this is x square with px, means 2IH cross x. Now you have 2IH cross x square and IH cross x square, that is 3IH cross x square. So this is how you can write. Okay, so what you can conclude here, when we have x square, you will get 2IH cross x, and when you have x cube, then you will get 3IH cross x square. So what you can write in general actually, now if you want to write in general, then what you can write, if you have x to the power n cap with px cap, that will be just NIH cross x cap to the power n minus 1. If you put n is equal to 2, then you will get this relation, and if you put n is equal to 3, then you will get this relation. So you can see, we can conclude with a general result when x to the power n and px cap, and we can remember this result to get your answer very quickly. Okay, similarly we can discuss px with x also. Okay, so as I have told you earlier, that if you talk about the px with x, then it will be just minus IH cross. Okay, but if you talk about px square, then it will be 2IH cross px cap. If you talk about py square, then it will be in that case, if this is also in the form of power, I want to say, if this is px square, something like. Okay, so let me tell you this. So let me avoid the calculation, but you can remember this result directly, something like this. Suppose you have instead in power of xn, you have pxn, suppose. So what will happen if you have x cap with px to the power n? In that case, you will end up with NIH cross, this will be same, but now it will be px cap to the power n minus 1. But if it is in this way, first if you have px to the power n and then x cap, then you will get a negative sign, then it will be minus NIH cross px cap n minus 1. And similarly you will get here also, if you have px cap, okay, if you have px cap, if you have px cap with x to the power n, then also you will get one negative sign here, minus nih cross xn minus 1. So this is how you can remember this result, the general result also. Okay. Now let me tell you about if you have py or pz also. So if you have py, the momentum operator py, this is actually minus ih cross del del y. Similarly, if you have pz, and that will be minus ih cross del del z. Now if you operate x with py, you will get 0 always. You can check this relation. This is I am giving you as a homework. So you can see if we have x with px, we have ih cross x. But when if you talk about x with py, or if you talk about x with pz, then also it will be 0. But if you talk about y with py, then you will get again ih cross y. Ih cross you will get. So this is how you should remember. So when x with x, px, y with py, and z with pz, you can get some commutative relation. But when it will be x with y, that means x with py or y with pz, these kinds of different kinds of thing, then it will give you the result 0. Okay. And one more thing you should remember, that if you have px with px, py, this will also give you 0 result. So when these two are different, then you will get 0 result always. So they will commute each other. So you should remember these kinds of commutation relation. Okay. In the next class we will discuss some more commutation relation for angular momentum also, some ladder operator and